Welcome to Gate Academy Global. In this video, we will be discussing A to Z about Fourier series, or I should say A to Z for solving a GATE exam question on the topic Fourier series. So target for me is, after watching this set of videos, you should be able to solve the coming GATE exam question on this particular topic. So let us start. So first of all, there are two types of Fourier series. First is trigonometric Fourier series. Second one is exponential Fourier series. First, I am starting with the introduction of trigonometric Fourier series. Simplest statement is any periodic signal can be expressed as sum of sinusoids. For example, f of t is any periodic signal. It can be written as a naught by 2 plus summation n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. We will try to understand all the terms, all the concepts required. We will be going to discuss in this particular video. Now, these A naught, An and Bn are called as trigonometric Fourier series coefficients. So, these are your trigonometric Fourier series coefficients. A naught is defined as 2 upon t, capital T. Capital T is the time period of the signal f of t. Integration over any time period t. I am going to explain what is this any time period t, f of t dt. An is 2 upon t, integration over any time period t, f of t cos n omega naught t dt. Bn is 2 upon t, integration over t, f of t sin n omega naught t dt. Now, coming to the first type of confusion a student may have is, some of you may have learned A naught here. Some of you must be thinking ki what you have learned earlier, it was written only A naught there. I am coming to that also. So that is what I am saying ki I will try to cover each and every smallest possible doubt you people are having in this particular topic. Okay, now see. So what some of you were thinking that A naught is written wherever you have studied. That is also correct. The only difference is, if you are writing A naught here, in the expression of A naught, you need to write 1 upon t instead of 2 upon t. Integration over time period t, f of t dt, both these expressions are exactly the same. So the simplest concept is, if I am writing only A naught here, this expression should be A naught is equal to 1 upon t. And if I am writing A naught upon 2, the expression should be A naught is equal to 2 upon capital T, and the same expression. So you should not at all be confused between the two. I will be using this one for a simple reason that if An and Bn are having 2 upon t in their expression, A naught should also have 2 upon t. For this, I am willing to write A naught by 2 in my standard Fourier series expression. Okay. Now you come to this point. See, this expression you must be knowing it very well. Integrating a periodic signal over one time period and dividing by the time period is nothing but the DC, or average value. It means this A naught is your average value. Now you come here. In this expression, if I go to the next step, this 2 I am writing here. So this will become a naught upon 2 is equal to 1 upon t integration over a time period t f of t dt. Simple step. This 2 I am replacing at this position. Okay? This 2 was here, I have written it here. Again, this is the expression of what? DC value or the average value. So this a naught upon 2 is your DC or average value. So this a naught upon 2 is my average value. See, I have shown you both the things just so that you should not at all be confused. So finally, what my suggestion is, or what I am going to use further, what I am going to use in the further questions is this concept only. Because I have already given you the simple reason, if an and bn are having 2 by t in their expression, I want a naught also to have 2 upon t in its expression. For this, at this position, I should write a naught by 2. Okay. So for now, from now, this is the trigonometric Fourier series expression with the following trigonometric Fourier series coefficient, and in this expression a naught by 2 is my average value, and value of a naught is 2 upon t integration over t f of t dt. So I hope this confusion, if you were having, it has been solved. Now let us move further. Now, okay, so this was an alternate Fourier series expression which I have written, continuing, or I can say expanding this summation. So what this summation means is that one by one I will put n is equal to 1, 2, 3, 4, 5, 6, 7. So just assume if I put n is equal to 1, this will become a1 cos omega naught t. Then I will put 2, a2 cos 2 omega naught t, and so on. Similarly in this position also. So what we are going to get is this one. See, that is a naught, the DC value or the average value we have discussed. Again I will show you here. This a naught or the DC value or the average value, same. Now expanding this summation. See, expanding this summation, this is a1 cos omega naught t, a2 cos 2 omega naught t, a3 cos 3 omega naught t, a4 cos 4 omega naught t, and so on up to infinity. b1 sin omega naught t, b2 sin 2 omega naught t, b3 sin 3 omega naught t, b4 sin 4 omega naught t, and so on. Now discussing more about the basics of this Fourier series, some basic points that we should know. For that I have just considered, let us consider a periodic signal f of t in this particular shape. It is being repeated from minus infinite to plus infinite. Okay. So first of all, what is the time period of this signal? Time period of this signal is, okay, see, this is the signal which is repeated infinite times from t is equal to minus infinity up to t is equal to plus infinity. Now what is the duration? What is the duration of this part of the signal? This is 4. So time period of this signal is 4. It means for this example, the value of t is equal to 4. The value of t is equal to 4. So now if by expression, if I want to solve this value of a naught, So it will become, see, A naught is equal to 1 upon t means 1 upon 4 integrating over a time period 4 f of t dt. Now what this integrating over a time period t means? It simply means the limit of integration can be from 0 to 4 and it is also possible that we can have from minus 4 to 0 and it is also possible to have from minus 2 to plus 2 and it is also possible to have minus 1 to plus 3. So we are making it very clear in this part that integration over a time period t means any interval whose duration is capital T, which is 4 in this example. 0 to 4, it is a duration of 4. Minus 4 to 0 is a duration of 4. Minus 2 to plus 2, it is again a duration of 4. Minus 1 to plus 3 is again a duration of 4. So this integral is now clear to us. Now coming to the next part. Next part about this omega naught. Next part about this omega naught. Okay. Now this omega naught, we already know omega naught is equal to 2 pi upon time period. We have considered a signal whose time period is equal to 4. We have considered a periodic signal whose time period is 4. So value of omega naught will be equal to 2 pi upon 4. It will be equal to pi upon 2. It will be equal to pi upon 2. So omega naught for this particular example is pi upon 2. So depending on the periodic signal given to you, you can put the value of omega naught here. It means this omega naught and this t are obviously related. This capital T is the time period of this periodic signal f of t. And this omega naught is also the angular frequency of this signal f of t only. So obviously this omega naught and capital T are related to each other. It means I can also write 2 pi upon capital T in place of this omega naught. It is exactly the same. So this time period is also of this periodic signal f of t and this omega naught is angular frequency of this signal f of t only. Okay. So now coming to the next point. So for this example, we have calculated value of omega naught is equal to pi upon 2. Now, it means in place of this omega naught, it should be pi upon 2. So what should be 2 times omega naught? 2 times omega naught will be pi. What will be 3 times of omega naught? It will be 3 pi upon 2. What will be 4 times of omega naught? It will be 2 pi. In the same way, this omega naught is also pi by 2. This 2 omega naught is pi. Obviously, I will be discussing all the things in the questions, in the form of questions also. But it is better if we can discuss it before solving a question so that when I come to a question, you should be able to solve before me only. Okay? So now this 3 omega naught will become 3 pi divided by 2. And this 4 omega naught will become 2 pi. So everything is known here. Everything is known to us now, nothing is hidden. Now, one more point I want to discuss at this moment. See, what are the frequencies present here? omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught, 6 omega naught, and so on. So basically, what are these? These are the multiples. These are the multiples of omega naught. And omega naught is obviously related with your time period. Omega naught is nothing but 2 pi upon t. It means this can also be written as 2 pi upon capital T. Sorry, yes, 2 pi upon capital T. This will be 2 times 2 pi upon capital T. 3 times 2 pi upon capital T. 4 times 2 pi upon capital T. One and the same thing. They are always related to each other. Now I am coming to this word. All these are multiples of omega naught. Basically, we use a term harmonics. We should be knowing this term harmonics. Harmonics is nothing new, but harmonics is multiples only. It means I can say this is the first harmonic. It means I can say this is the first harmonic. First multiple means first harmonic, second multiple means second harmonic, third multiple means third harmonic, fourth multiple means fourth harmonic. So harmonic means multiples. This is the second harmonic. This is the third harmonic. This is the fourth harmonic, and so on. Now, this first harmonic, this third harmonic, all of them are also called odd harmonics. And the second harmonic and fourth harmonic will be called as even harmonics. We are going to use all these terms, so I am trying to define it in the basics part only. So this was all about the basic introduction of trigonometric Fourier series. So obviously we are going to use all of them in the questions. So just wait and watch how we apply all these concepts on the previous year GATE exam questions. Now coming to the next concept, if I consider f of t to be an odd signal. Just if I assume that the given periodic signal is an odd signal. So now if f of t is an odd signal, obviously this signal is an even signal. Multiplication of odd and even will be an odd signal. And we know integration of an odd signal over a time period will always give you 0. So the simplest conclusion is, if f of t is an odd signal, a of n will be equal to 0. See, if f of t is an odd signal, a of n will be equal to 0. It means f of t will be equal to a naught upon 2 plus summation n is equal to 1 to infinity, an is equal to 0, so this will be become bn sine n omega naught t, like this. See, this an becomes 0, so this summation contains only bn sine n omega naught t. So I will make a small update here. This will be sine n omega naught. So this will save us time of solving expression of an. Now I don't need to solve the expression of an, it will become 0. And this will be the resultant trigonometric Fourier series. Now consider f of t is an even signal. So this f of t is an even signal. and this sign is an odd signal. Again, multiplication of an even signal with an odd signal is an odd signal, and integrating an odd signal over a complete time period again will give you 0. So the conclusion is, for an even signal, Bn is equal to 0. Come. If f of t is even signal, if f of t is even signal, Bn is equal to 0. So now the resultant Fourier series will become a0 by 2 plus summation n is equal to 1 to infinity. Now this time Bn is equal to 0, so we will get an cos n omega naught t. See, it simply means, it is very simple conclusion. If f of t is an odd signal, it will contain only the odd part, means it will contain only the sine harmonics. It will contain only sine terms. And if it is an even signal, it will contain only cos terms. So it is very simple result. If it is an odd signal, it should contain only sine terms. It does not contain any cos terms because an is equal to 0. Again, if a signal is an even signal, it will contain only cos terms. It will not contain any sine terms. It is not containing any sine terms because Bn is equal to 0. So this simple fact we have to remember, and after some time I will introduce a concept, half wave symmetry. I will introduce a concept, half wave symmetry, then I will discuss what is half wave symmetry and what are the conclusions if a signal is half wave symmetric. So this is the conclusion when the given periodic signal is odd. This is the conclusion when the given periodic signal is even. After some time, I will discuss what is a half wave symmetric signal and what are the conclusions for half wave symmetric. And one very important point, in the later stage, I will discuss about hidden half wave symmetry also, which is very important with respect to your GATE exam. So just I want to add one more point before going to the next concept. For example, we are considering, let's say, if f of t is an odd signal, considering f of t to be an odd signal. So this f of t is an odd signal. So again, this is introduction of an odd signal directly. An introduction of odd signal over a time period is obviously equal to 0. It means if f of t is an odd signal, a naught is also equal to 0. So if f of t is an odd signal, also a naught is equal to 0. So I can further reduce it to summation n is equal to 1 to infinity Bn sine n omega naught t. Okay. So this was the simple justification. If f of t is an odd signal, this is directly integration of an odd signal over a time period t, which is always equal to 0. So this a naught is also equal to 0 if your signal is an odd signal.